All right, so here we go. Last video we did was we solved these three trig equations, and here is the video on how to check easily with your graphing calculator by using Zoom Trig. So when when you're solving on 0 to 2 pi, Zoom Trig works very nicely. And if you can read the graph correctly, you don't even have to change, you don't even have to check your mode. You could be in degree or radian and it won't matter. So first of all, you're going to have to plug these into the calculator in the y equals screen. So always, when you do that, set it equal to 0. That's what will help you find the solutions because you are finding the zeros. Therefore, the 4 sine x plus 9 equals 7. When I typed it in, I typed it in as 4 sine x plus 9, and then I brought the 7 over and put minus 7. And I'm going to, before we look at them, I'm going to show you how I typed in the rest of them, the last three. Um, the next one is the trickiest one because we don't have a cosecant on our calculator. So remember, cosecant is the reciprocal of sine. So it's 1 over sine. But you have to square that whole thing. So when I typed it into the calculator, the 5 cosecant squared, I typed it in as 5, and then in parentheses, the 1 over sine. Close my parentheses and hit square, and then minus 10, because it's already equal to 0. And the last one, just type it in. You just have to be careful with the cosine squared. If you just type cosine x and then hit square, it should work on the calculator. I don't like that too much because that's really saying cosine x squared. Regardless of the fact, I want to make sure I tell my calculator I'm trying to square the entire cosine x. So I'm using these parentheses out here, and then add cosine x. And then there was a plus 3, and I brought this 3 over and made it minus 3. So now we're just going to look at the easy checks. So I'm starting with the first one, the 4 sine x plus 9 minus 7. When I hit the normal graph, doesn't really tell me much about it as far as how it acts on 0 to 2 pi. So when I hit Zoom Trig, that will give me the exact locations on the circle. So here we go. Let me do this. So here's what the graph looked like in Zoom Trig. Remember, what Zoom Trig does is it breaks this down into quadrants. So what this is saying is the first quadrant, which is right from here to here, there's no solutions. The second quadrant, there's no solutions. The third quadrant, here's one solution, and that's early in the third quadrant because that's early because it happens before halfway. And then it goes to this fourth quadrant, and this is late in the fourth quadrant. So that tells me the solutions are this. Early in the third quadrant would mean the first spoke in the third quadrant. Late in the fourth quadrant would mean the second spoke in the fourth quadrant. And that's what my unit circle should look like. And if you look at our solutions we got before, that's exactly how I mapped out my solutions. Early in the third, late in the fourth. So it's a great check. And you can just draw your unit circle almost based off that. So let's look at the next one. Let me get rid of all this stuff. All right, so the next one was the 5 cosecant. So on my calculator, I'm just going to turn off the sine and turn on the next one. This will be in red. There we go. So look, if you look really closely, it looks like it's cutting those quadrants right down the middle. So like the first quadrant you can see is right here. And it's going right through the middle of the first quadrant, which would mean it's the pi over 4 circle because that's the one that has the middle spokes. So I won't spend a lot of time on this one because it's the middle on the first, middle on the second, middle on the third, middle on the fourth. So it's all the pyrophore spokes. And if you notice when we went to solve it, that's exactly what we got, all the pyrophore spokes. Now, this is really, really important, I think, to check this, because a lot of times if you watch this video on how we solve this, we got a plus or minus when we square root both sides. A lot of people forget the plus or minus and would only get the two positive answers. But as soon as you graph it, you can see that it's not only the two positive, it's every single spoke. So that's a really good and important check, in my opinion. And my opinion is the only opinion that matters. Not really, but my opinion is always a correct opinion. Anyhow, next one. So I'm just going to quickly turn off the second one and then turn on the third one. And then there's my graph. Now, this is a slightly different because this is not going inside any of the quadrants. Look, do you see how it goes exactly that line between the first and second quadrant? Well, that indicates between the first and second quadrant, here's the first, here's the second, that indicates that solution is right there. And then it hits right here between the second and third quadrant, second and third, so that's this. And then finally it hits between the third and fourth quadrant, which is 1, 2, 3, here's 4, so that would be down here. And then the last quadrant, it doesn't go through here. So that's it. Those are the three solutions. As you can see, that's exactly what we got. You can't see because I can't get rid of this. There you go. You can see that's exactly what we got. Compare this circle right here from the graph with this circle when we did it by hand, and you'll see it's exactly the same. So it's a really, really good check, really useful. And you really can't get these problems wrong if you're good at checking. So hopefully that helps, and I will see you in the next video.